This laptop was not built for excitement. It was not intended for gaming or home use. It was meant for people who needed to travel with data. Its purpose was straightforward: run the business software reliably. The data on machines like this mattered, and it had to be backed up. In this video, that's exactly what we're going to do. This is a Toshiba Satellite Pro 4600 series laptop. It was part of Toshiba's value business line released in 1999, and it had all the features a travelling employee would need. There are a blend of high-performance technology at an affordable price, available with Windows 98 SE, Windows NT 4 or Windows 2000 operating systems. This one comes with Windows 98 SE. There is a Kensington lock for security, adequate cooling and a straightforward hardware switch for power and battery. Dual PCM CIA slots were important for business users, common cards being SCSI and Token Ring. Wi-Fi was optional. The design includes space for it, even if the card is not installed on this model. On the right side of the laptop, there is a floppy disk drive, headphone, mic jack and a handy volume control, infrared port and modem for transferring data, a CD-ROM drive, and finally the extremely important Ethernet connection. At the rear of the laptop are the essential connections: power supply, PS2 port, TV out, which was rather uncommon, VGA for external displays, an expansion port for docking, and both serial and parallel ports, finally 2 USB ports, which were starting to appear on business laptops at the time. On the front of the laptop are 2 decent speakers and an array of system LED lights. The rear of the laptop hides the Windows 98 SE product key and Cell 650 6410G, referring to Celeron 650 with 64 MB of RAM and a 10 GB hard drive. Here I have the marketing flyer for the Toshiba Satellite Pro 4600 series. The premium model is a Pentium 3 1000 with 256 MB of RAM, 15-inch TFT colour display and a CD rewriter DVD-ROM. In 1999, this was a very high-spec laptop and possibly was treating the employee to the ability to watch DVD films while travelling. This is the HP Colorado T1000E backup drive, a type of tape drive that would have been common for a person to carry with them to back up their important data. Power is supplied through a standard IEC C13 connector, which is the same type used for a desktop PC. Data is carried over the IEEE 1284 parallel port connected directly to the laptop, and importantly there's a pass-through parallel port so you can connect a printer in a daisy chain without needing to unplug anything. The tape drive may operate over the parallel port, but it requires a different cable than the one you would use to a printer. Specifically, this must be a DB25 IEEE 1284 cable, because the cable needs to carry data bidirectionally. Colorado tape drive uses a variant of the Travan Tape, which is an 8mm magnetic tape in the QIC physical format. Often these tapes degrade over time. However, lifting the flaps reveals the actual tape itself. I can see the tape's in good condition. It's not sticky or damaged in any way, making me hopeful that these tapes will be usable. The Travan TR-1 cartridge I am using has a native capacity of 400 MB and a transfer speed of 0.25 megabits per second, meaning that backups were likely to be something you left running while you had your dinner. The drives were noisy, and the time taken to recover an entire backup set would be in hours rather than minutes. With the tape drive connected to mains power, I insert the cartridge. Normally I'd reduce background noise, but here I've left the audio untouched so you can hear exactly how loud these tape drives were when in everyday use. To put that in context, here's a decibel reading taken directly next to the drive. This was not a system designed for aesthetics, it was a practical hardy tape drive designed to work reliably. The Toshiba 4600 laptop requires a specific voltage of 15 volts. I select this on my multi-voltage power adapter. Before booting the operating system, I check the BIOS on the laptop using the F1 key. Toshiba had quite a limited BIOS compared to other laptops at the time because they used Windows applications to control settings on the laptop that many other manufacturers put in the BIOS. You can see here on screen that there's very little to change. I check the parallel port supports bidirectional function for the tape drive. I save the settings with the N key and let the laptop restart. I'm going to switch to full screen on Windows 98 for clarity. Before I install Colorado Backup, I need to transfer it from my Mac. Again, I'm going to use the Python HTTP server I've got running on my Mac to easily transfer that file across. The application didn't come in a zip file. I've zipped it up for convenience of transfer, so I'll unzip it now and get to installing disk 1 of the 5 disks it takes for this version. The installation is fairly straightforward, and because I unzipped each disk file to the same location, I don't have to swap disks as you would have done with floppies that originally came with the drive. There's something quite nostalgic about the gradient blue that was used on so many installation packages of this era. And as the installation progresses, the dialog boxes show an aesthetic hint of that transitional period between Windows 3.1 and Windows 95. The JET database on screen was the same one used in Microsoft Access. Next, the application will attempt to detect the parallel port tape driver that I've connected. The backup application is installed, and I go to Device Manager on my computer to check if the tape drive is showing up as hardware. And there is success. The tape drive is showing as the Colorado QIC-80. But because this is Windows 98, I will restart the laptop to give Colorado Backup a chance to detect the tape drive on startup. After logging in, Windows detects the parallel port controller, which is the one that I'm using with this external tape drive, and then the floppy disk controller, which would have been used with the internal QIC-80 Travan Tape drive. Launching Colorado Backup, I skip past the recovery disks, as these would only be needed when you do a complete bare metal recovery of the laptop. At this stage, that's not a backup I'm going to undertake. After a few seconds of initialization, I select the Tools menu. I can see the commands for the use of the tape drive are all greyed out, which means Colorado Backup cannot detect the tape drive. A quick look through the settings also shows there's no further configuration I can do in the program to get it to detect the tape drive. I decided to close the backup application and go into Device Manager again, and I can see that the tape drive is loaded as it was before. I check the Shuttle EPAT external ATAPI adapter, which is the software that controls the connection through the parallel port. This is working correctly and is in auto mode, which is what's required. So the question is, why does Colorado Backup not see the tape drive? My troubleshooting instincts kicked in and tells me that I got an alternative option, which is to use the built-in backup of Windows 98 that was called MSBACKUP. This was actually a version of Seagate's own backup product that Microsoft had licensed. Once this loads up, I can see immediately in the bottom left of the application the QIC-80 tape drive is detected, which is exactly what I would have expected because Windows can see the tape drive. My conclusion on this is that the Colorado Backup I've installed, although for Windows 95-98, must have had specific drivers for this tape drive that I don't have. The drivers that I've used in order to get Windows 98 to see the tape drive are not compatible with Colorado Backup, and therefore it doesn't see the tape drive. This is one of the Travan TR1 backup tapes I bought off eBay. It says Win95 on the label, although it's a little hard to see in the light. The tape's extremely well made, and as you can see, when I release the shutter on the magnetic tape, it's in excellent condition. This gave me significant hope that we were going to be able to use this tape for a backup and recover any data that might be kept on it. Back on the Windows 98 laptop and in Microsoft Backup, the Restore tab asks to refresh the view, which is a temporary catalogue of the tape. After a brief scan of the tape header, I can see that a backup set is on the tape, and this is called 7-Day Cycle All Files Drive C. The tape contains two backup sets from the 19th and 20th of April 1997. This is pretty impressive stuff for a tape that's 29 years old. Often Travan tapes degrade over time, however these have been stored in a location that kept them in good standing. Microsoft Backup now reads the tape in order to catalogue all of the data that's available for restoration. A message pops up on screen to explain there's another tape in this media set. However, I don't know if I have that or not, so I'm going to choose no. The catalogue process is completed and the What to Restore section on screen shows that we have a backup of a Windows 95 computer. Expanding the backup set, this looks like a very typical backup of its era. I suspect this was a computer that may have been used as a server by this business. The list of names in my document folder hints that my documents were shared across the network to other computers. To recover this, I'm going to create a dedicated recovery folder to test the tape drive's recovery speed for the data. I select the My Documents folder for restoration, and looking through some of the other folders on the backup set, it looks like there are some database files, possibly Microsoft TechNet, a DOS folder which hints at this was an upgrade, and several other folders for various applications. I then choose to restore the My Documents folder to the new Tape 1 Restore folder I've created on the laptop. Selecting the options for the restore, you can see some of the classic options available. The one that is selected by default, do not overwrite existing files on my computer, This protected you from overwriting a more up-to-date version of a file that you had. Reporting will be minimal, showing you what was missed rather than recording everything that's been restored. And at the bottom of the report page, I do want to see any pop-up messages, so I do not make this an unattended restore. The last option on the Advanced tab is to restore the Windows registry. This shows that this backup tool was designed for a complete bare metal recovery of a laptop. I start the recovery and select the media set that we have catalogued, untitled 0001. The tape drive whirs back into life and begins to restore the files to the laptop. For brevity, I've sped up this entire process so we can save a little bit of time. Time for restoration, 4 minutes 38 seconds, recovering 273 files. Selecting the report button shows no errors in the recovery and a simple overview of the recovery status. I then browse the recovery folder back on Windows 98 and you can see all of the files have been recovered and are available to open. I select the Cleaning the Keg Pipes Word document to test if the file can actually be opened after restoring. This was always critical. Never assume your restoration was valid until you tested it. The file opens in Word 97 and, indeed, describes the process for cleaning the pipes in a public house. I checked the Bob folder and switched to the Details view. Everybody has their personal preferences, but mine is always the Details view. I browse over to the Hill folder and see that it contains several TIFF images. Opening one of these shows a very close-up of what appears to be an ordnance survey map. As I continue to browse the restored data, I want to state that this data is archival history and is exactly as I found it on a tape purchased on eBay. It's at least 29 years old. It contains no personally identifiable information. Once the video recording is completed, I will format the tapes and delete all this information from the laptop. The next test is to see how long it takes to back up the entire laptop. I stick to the simple defaults of all folders and files. Verifying the backup was a default setting. This meant the backup application would then verify that everything on the tape was as expected. This also pretty much doubled the time it took for the whole backup process. A critical setting was compress data to save space on the tape, because the Travan TR-1 tape has a maximum capacity of 400 megabytes. I named the backup and let it get started. After estimating all of the data stored on the laptop, it's come back to approximately 1.3 gigabytes. Clearly this is not going to compress and fit onto a 400 megabyte tape. This was a common challenge for those who wanted to back up an entire laptop, as they had to swap tapes to back up all their data. The backup states that the tape needs to be erased to complete the backup. I choose erase because I was going to wipe the tapes anyway. After about 6 minutes of backup, the software can estimate the compression gain, and I highlight this on screen to show that the compression ratio is 2.17 to 1. This theoretically means the backup set could contain up to 800 megabytes of data. However, it all depended on what files you were backing up. You can get great compression on Word, Excel, PowerPoint files, likely achieving the stated 2 to 1 compression ratio. Database files will be slightly less, as they naturally contain their own compression. Bottom of the list would be JPEGs, TIFFs and MP3 files. These already contain compression and you would see a ratio of 0. There's no more compression that can be gained with those files. As the backup continues to run, it estimates how long it will take to complete. At around 6 minutes, this stands at 2 hours and 32 minutes. Sometime later, the backup is still running and 1 hour 3 minutes have passed, yet 2 hours 31 minutes still remain. It was very much a fool's errand to rely on the estimated time shown on backup applications. The backup continues and at 1 hour 3 minutes the maximum storage capacity is reached, prompting a request for a new tape. 452 megabytes written to the tape with a compression ratio of 1.14 to 1. As you can see, pretty poor. It was a true challenge to back up an entire laptop in the late 1990s. It's highly likely that between 3 and 4 tapes would have been required to back up this laptop. It's been a really interesting challenge getting this tape drive to work with Windows 98 laptop. I certainly had to dig deep into my memory to remind myself how I would have set one of these up way back when. First, that meant getting the correct parallel cable, and suffice to say, it was the third cable that I ordered that was correct. I had forgotten I needed the specific IEEE 1284 cable for data transfer. Really enjoyed the fact that the Toshiba laptop worked so well. It was a real find on eBay. Together the two have made a realistic scenario for the travelling salesman or engineer that would have used this back in 1998. And the video highlights how difficult this was, how many tapes were involved, how long the process took and how noisy it was. Despite all the rules from head office, nobody was backing up laptops every night, no matter what the policy said. It makes you realise how easy we have it today in the world of synchronised cloud folders where you don't even need to think about what you're saving anymore. It's saved automatically. My next thought is to make a video that takes this a little bit further. Can I back up and recover an entire Windows laptop, making the assumption that the hard drive's failed, and what will it take to do it? That's going on the list, and I'm going to start preparing what's needed to achieve that. I hope you enjoyed the video, and if you've got any experience of working with this kind of hardware, I'd love to hear about it in the comments. Thanks for watching, and I'll see you on the next video. Ta-da!